shining. You're in class just in time. All right, 12.6, the last section we're going to do in chapter 12, and this is on inverse variation. Now remember, with direct variation, if we doubled the x, the y doubled. If we tripled the x, the y tripled. But with inverse variation, as one variable increases, the other decreases, okay? And your products are going to be constant. In other words, y is equal to k over x is inverse variation. So if I were solving for k, x times y would be equal my k. So the products of x and y is going to be the same every time. So if we said that, the distance and the time that it took to drive, like if we, the rate. If I was driving 60 miles an hour in 3 hours, okay, I'd be getting 180, right, miles. So if I increase my speed to 90, it's only going to take me 2 hours, right? So as one variable increased, the other decreased, okay? So that's the kind of deal we're working with inverse variation. So when you saw direct variation, you know it's y equals kx, right? That's direct. If you have inverse, you're going to remember y equals k over x, all right? So we're going to do the same thing as we did yesterday. We're going to be given two values. We're going to find the constant, plug it into an equation, and then find a new value. All right, so hopefully you're on page 561. We're going to do the first example, and it says find an equation of variation where y varies inversely as x, where one pair of values is y is 145 and x is 0.8. All right, so I'm going to plug in 145. I'm looking for the constant. The x is 0.8. All right, so think about this. If this were over 1, wouldn't I cross multiply? So 1k is 145 times 0.8. So my constant here is going to be 116. So I'm not done. I write the equation of variation under these conditions. This is my answer. All right? I plugged in the y and x in the right equation, found the constant, and then wrote the equation of inverse variation with the constant that I found. Okay? All right, take a minute to try this A and B, and then join me. So I plugged into y equals k over x because it said inverse variation. So 105 is k over 0.6. I multiplied those, got 63. So my equation of inverse variation under those conditions is this. For B, plugged in the numbers, got my k, and got my equation. All right, so just like yesterday, we're going to have a word problem. All right, so example 2 on page 562. The pitch, okay, so P, of a musical tone varies inversely as the wavelength. All right, so instead of y equals k over x, I do p equals k over w. So one tone has a pitch of 660 vibrations per second and a wavelength of 1.6. So I'm looking for the constant under those conditions. Okay, so my constant will be 1056. So now I'll say that P equals 1056 over W. I'm now supposed to find the wavelength. So I'm finding the wavelength when we have a pitch of 440. Okay, so 440 equals the K that I found over the W. All right, so think about what I'm doing here. So 440 W equals 1056, cross multiplying. So W will be 1056 divided by 440, so 2.4. All right, go back through if you need to watch that example again, or look at the book. And let's do C and D. Last try this of the chapter. All right, so C, time varied inversely as the rate. So it took 5 hours at 60 miles per hour, or kilometers, I don't know. So K, 1K is 300. So I plugged the constant into the equation, and it wanted me to see how much time for going at a rate of 40. So I crossed out my zeros. 30 over 4 is 15 halves, which is 7.5 hours, okay? And then time varied inversely as the number of people. So it took 4 hours for 20 people. My constant was 80. How long would it take for 25 people? 3.5 hours. All right, assignments in RenWeb. Make sure that if you're ever turning in work, you turn it in by 3 o'clock, that it is neat and legible, that you show your setups of your problems. Do not just give me an answer key. You could copy that out of the book, I know that. Be honest, be diligent. Hang in there, guys. Have a great day.